Welcome to Science Plus History channel. Kindly subscribe for historical, extraterrestrial, and science videos and click on the bell icon for notification for new videos. What would a million-person Mars colony look like? If and when human beings settle on Mars, a number of things need to be addressed beforehand, not the least of which are food, water, housing, protection, and transportation. There is no shortage of people today who have an opinion on whether or not humans should colonize Mars. On the pro side, there are those who think that a Martian settlement will serve as a backup location for humanity in case some cataclysmic event happens here on Earth. On the con side, there are those who feel that focusing on Mars will steal focus away from efforts to save planet Earth. There are also those who think the natural hazards make it a bad idea, while people on the flip side think it is these very things that make it an exciting challenge. But when you look past the arguments for and against colonization, there is the inevitable question of if we can settle on Mars and what that settlement would look like. The question goes beyond mere aesthetics and embraces everything from architecture and construction to food, transportation, and general health. So what exactly would a colony on Mars look like and how would it operate? Making a go of life on Mars. To be fair, there is no shortage of ideas for how human beings might establish a colony on the red planet. They are also quite detailed, ranging from different kinds of structures that could be built, how they would be built, what they would be built from, and how they would be protected from the elements. Then again, they would have to be in order to address the many challenges that living on Mars would present. These include, but are not necessarily limited to: extreme distance from Earth, unbreathable atmosphere, extreme temperatures, increased exposure to radiation, planet-wide dust storms. Taking all of this into account, it becomes clear that any efforts to build a civilization on Mars will have to take into account a lot of specific needs. And meeting these will necessitate that colonists rely pretty heavily on some pretty advanced technology. Habitats will need to be sealed and pressurized, heavily insulated and heated, shielded against solar and cosmic radiation, self-sufficient in terms of water, power, and other essentials, and built, as much as possible, using local resources, aka in situ resource utilization, ISRU. Getting to Mars. Using current methods, the journey to Mars is long and potentially dangerous and can take place only when Earth and Mars are at the closest point in their orbit to each other. This is what is known as a Mars opposition, where Mars and the Sun are on directly opposite sides of Earth. These occur every 26 months, and every 15 or 17 years, an opposition will coincide with Mars being at the closest point in its orbit with the Sun, aka perihelion. On average, Mars and Earth orbit at an average distance of 225 million kilometers, 140 million miles. But during an opposition, the distance between Earth and Mars can drop to as little as 55 million kilometers, 34 million miles. However, since it is not exactly a direct flight, the travel time involved is not a simple matter of calculating the distance divided by average velocity. This is because both Earth and Mars are orbiting around the Sun, which means you can't point a rocket directly at Mars, launch, and expect to hit it. Instead, spacecraft launched from Earth need to account for the moving nature of its target to be pointed at where Mars is going to be, a method known as ballistic capture. Another factor to consider is fuel. Again, if you had an unlimited amount of fuel, you'd point your spacecraft at Mars, fire your rockets to the halfway point of the journey, then turn around and decelerate for the last half of the journey. You could cut your travel time down to a fraction of the current rate, but you would need an impossible amount of fuel. Because of this, a mission to Mars can take between 150 and 300 days, 5 to 10 months to reach the red planet. This all depends on the speed of the launch, the alignment of Earth and Mars, and whether or not the spacecraft will have the benefit of slingshotting around a large body to pick up a boost in velocity, aka a gravity assist. Regardless, crewed missions invariably require spacecraft that are larger and heavier than robotic spacecraft. This is necessary since human beings require amenities while in space, not to mention the number of supplies and equipment they'll need to carry out a mission. Martian housing. The challenges posed by long distance and natural hazards on Mars have led to some creative suggestions of how to build habitats that will shield against the environment and can be built in situ. Many of these ideas have been proposed as part of an incentive challenge sponsored by NASA and other organizations. Some examples include the MakerBot Mars Base Challenge. This joint competition, which ran from May 30 to July 12, 2014, was hosted by NASA JPL and MakerBot Thingiverse, a Brooklyn-based 3D printing company. For the sake of the competition, entrants were given access to MakerBot 3D printers and tasked with designing bases that were utilitarian, capable of withstanding the elements, and providing all the amenities of home. Of the over 200 ideas that were submitted to the competition, 2 were selected as the contest winners. These included the Mars Pyramid, a design that was inspired by the Pyramid of Giza. This particular structure was designed to withstand the worst of the elements while also being configured for science and engineering activities and experiments. The sides of the pyramid would be composed of solar panels to collect energy and provide the inhabitants with vistas to combat feelings of isolation. A nuclear generator would provide backup power, water would be stored near the main power center and heated as needed, and food would be grown with a sustainable aquaponics system at the top of the pyramid. The second winner was the Mars Acropolis, a futuristic design that incorporated carbon fiber, stainless steel, aluminum, and titanium into the main structure while a combination of concrete, steel, and Martian soil formed the outer protective wall. The main structure would consist of a foundation and 3 levels that accommodated different functions and facilities. Artists' concept of the Mars Pyramid. On the ground level, decompression chambers would protect against a loss of air pressure while a series of greenhouses would produce food and help filter the air and produce oxygen. Level 1 would house the water purifier while Level 2 is where the living quarters, labs, and a landing dock would be placed. Meanwhile, Level 3 would act as the nerve center, with flight operators and observation posts and the colony's water reservoir. This reservoir would be situated at the very top of the settlement where it could collect atmospheric water, condense it for use by the inhabitants, and use the sun's energy to warm it. Journey to Mars Challenge. Announced in May 2015, this NASA-sponsored incentive competition sought to inspire creative ideas from the public that would allow for continuous habitation on Mars. According to the guidelines, NASA was looking for ideas that would address issues of shelter, food, water, breathable air, communication, exercise, social interactions, and medicine. In addition, all of the submissions needed to focus on resource efficiency, feasibility, comprehensiveness, and scalability in order to facilitate missions that are longer in duration and greater in distance from Earth, eventually approaching Earth independence. This particular design relies on the abundance of water and the perennially cold temperatures in Mars' northern latitudes to create a habitation for explorers. The construction would be handled by autonomous robots that would harvest ice on site and combine it with water, fiber, and aerogel, which would then be printed as layered rings. This method and choice of building materials would provide insulation, radiation shielding, and a view of the surrounding environment to potential Martian settlers. Dodecahedral modules to form the basic shape of the habitat while a series of semi-autonomous robots then use microwaves to melt and distribute regolith, aka sintering, over these to form the habitat's protective outer layer. And unique architectural designs to fashion highly functional habitats out of the Martian environment. Hawaii Space Exploration Analog and Simulation, aka HI-SEAS. Using an analog for a habitat on Mars, located on the slopes of the Mauna Loa volcano in Hawaii, this NASA-funded program conducts research missions designed to simulate crewed missions to Mars. At an elevation of 2,500 meters (8,200 feet) above sea level, the analog site is situated in a dry, rocky environment that is very cold and subject to very little precipitation. Once there, crews live in a habitat where they carry out tasks that would be similar to a Mars mission, which includes research, missions to the surface in spacesuits, and being as self-sufficient as possible. The habitat itself is central to the simulated mission, consisting of a dome that is 11 meters (36 feet) in diameter and has a living area of about 93 square meters (1,000 square feet). The dome itself is airtight and has a second level that is loft-like, providing a high ceiling to combat feelings of claustrophobia. The 6 people in a crew sleep in pie-slice-shaped staterooms that contain a mattress, a desk, and a stool. Composting toilets turn their feces into a potential source of fertilizer for the next mission, an exercise station provides for regular workouts, and communications conducted via email with a simulate the time lag. Other ideas include the Mars Ice Home, an idea put forth by NASA Langley Research Center in conjunction with Search and Clouds OW. After winning the Mars Centennial Challenge, NASA partnered with these architecture and design firms to help expand on their prize-winning proposal. An artist's rendering of the Mars Ice Home concept. Credits: NASA Clouds OW. Search. The updated concept relies on an inflatable dome and detachable decompression chamber, which are lightweight and can be transported and deployed with simple robotics. The dome is then filled with locally harvested water to form the protective main structure. The ice home also doubles as a storage tank that can be refilled for the next crew. It can also be potentially converted to rocket fuel at the end of the mission if needed. Population. One of the more difficult questions to answer about Martian settlement has to do with the number of people involved. In short, what is the maximum number of people that could be sustained in a single colony? And if these people were effectively cut off from Earth, how many would there need to be to keep a self-sustaining population going? In this case, we are indebted to a series of studies conducted by Dr. Frederick Marin of the Astronomical Observatory of Strasbourg. What they determined was that a minimum of 98 people would be needed in order to sustain a healthy population where the risks of genetic disorders and other negative effects associated with intermarrying would be minimized. At the same time, they tackled the question of how much land would be needed to sustain them. Given that dried food stocks would not be a viable option since they would deteriorate and decay during the centuries that the ship was in transit, the ship and crew would have to be equipped to grow their own food. Artists' concept of a subsurface Martian settlement. Here, they found that for a maximum population of 500 people, at least 0.45 square kilometers (0.17 square miles) of artificial land would be needed. From this amount of land, the crew would be able to grow all the necessary food using a combination of aeroponics and conventional farming. These calculations can be applied to a Martian settlement very easily since most of the same considerations apply. Food production. Another big issue of living on Mars is the challenge of producing enough food to sustain a colony of humans. Given the distance between Earth and Mars and the fact that supply missions would only be able to arrive once about every 2 years, there is a strong need for self-sufficiency when it comes to things like water, fuel, and crops. To date, multiple experiments have been conducted to see if food can grow in Martian soil. In the early 2000s, experiments were conducted by researchers from the University of Florida and NASA's Office of Biological and Physical Research. This consisted of seeing how plants would grow when subjected to Martian pressure conditions. Another experiment involved using Earth bacteria to enrich Martian soil, specifically, cyanobacteria croococcidiopsis. This bacteria is known to survive in extremely cold and dry conditions on Earth and could help convert the Martian regolith into the soil by creating an organic element. In 2016, NASA teamed up with the Lima-based International Potato Center to test if potatoes could be cultivated using Martian soil analogs, which were created using Peruvian soil. This experiment was conducted for 3 reasons. On the one hand, the arid conditions in the region served as a good facsimile for Mars. In parts of the Andes, precipitation is similarly rare and the soil is extremely dry, just like on Mars. In spite of that, the Andean people have been cultivating potatoes in the region for hundreds of years. But perhaps the greatest draw was the fact the experiment calls to mind the scenes in The Martian where Matt Damon was forced to grow potatoes in Martian soil. In short, it was a spectacular PR move for NASA at a time when it is looking to drum up support for its proposed journey to Mars. In recent years, Mars One, the nonprofit that recently declared bankruptcy, also conducted experiments to see which crops would grow best in Martian soil. This took place between 2013 and 2015 in the Dutch town of Nergina, where teams from the Wageningen University and Research Center planted crops in simulated Martian and lunar soil provided by NASA. Over time, the teams tested different kinds of seeds along with organic nutrient solution to see which ones would grow in a lunar and Martian environment, with the same seeds growing in Earth soil as a control. The team confirmed that rye, radishes, garden cress, peas, tomatoes, and potatoes could all germinate nicely and produce more seed for the next harvest. Conclusion: any proposals and ideas, a picture of Martian settlement begins to appear. This is in keeping with our growing interest in Mars and evolving plans to explore the planet. And while the challenges may be great, the proposed solutions are both innovative and potentially effective. Well, if you would like to get more updates, all you have to do is like, share, and leave a comment below.